Hello again, everyone, and welcome in the third part of chapter Experimental Techniques. During this video, we'll be talking about the methods of purification, and we will see the difference in mixtures of solid and liquids and the methods of separation between them. The methods of purification, such as filtration, crystallization, simple distillation, and the fractional distillation. The choice of the method of separation depends on the nature of substances being separated. For example, if we have mixtures of solids, in this case, the separation will be based on differences in density, the magnetic properties, or the sublimation and solubility. For example, if we have a mixture of iodine, which is a solid sublime at hot temperature, plus sand, we can separate between them by using the fact that I2 can sublime, which means by heating the mixture, I2 will sublime and change into vapor, so we can collect it by decreasing the temperature of the gas, for example, and crystallizing it on the surface of a cold jar, for example. And also now, talking about the mixtures of liquids, and let's take, for example, the immiscible liquids, which are liquids that do not dissolve in each other. For example, a mixture of water and oil. We can separate between them by using a separating funnel, as you can see in the picture here on the right hand side. The mixture of two immiscible liquids can also be separated using decanting, which means pouring carefully. By letting the mixture to set, it will be separated, which means that we'll be having two layers. We can then decant the first layer, as you can see in the following figure. To separate an undissolved solid from a mixture of a solid and liquid, for example, sand from a mixture of sand and water, we can use filtration, in which the filter paper allow only the small particles of the liquid to pass through it, which means here we will be having a filtrate. Then the solid particles, which are too large, they will stay behind as a residue in the filter paper. Also, centrifugation can be used to separate between an undissolved solid and a liquid. Crystallization can also be used as a method of purification, in a way to separate a dissolved solid from its solution. On the following figure, we represent copper sulfate in its hydrated form and in its anhydrous form. So in this case, its formula is CuSO4, which is containing actually 5 molecules of water, and its color is blue, as you can see here. But in the anhydrous form, this means that those crystals lose their water of crystallization, which means that the formula here is CuSO4, which means that there is no water of crystallization in this form, which is white color. Now, by dissolving CuSO4 crystals in water, we can make an aqueous solution, as you can see here or here. So now if we would like to go back, which means by proceeding crystallization, starting from the aqueous solution to form the crystals. If we would like to go back to form those crystals, we can proceed by crystallization. So to do that, we will be using an evaporating basin in which we will be pouring our solution. Then by heating the solution to evaporate the most of the liquid, we can dip a glass rod inside the solution and taking it off. If some crystals are formed on the tip of the glass rod, we can see that we reached the stage in which we have a saturated solution. At this stage, we can stop heating, then we will leave the solution to cool. Then the solid crystals will appear on the evaporating basin. After that, those crystals are collected and dried by pressing them between two sheets of filter paper. After that, we will be reforming our crystals, which are the CuSO4 5H2O crystals. Now, to separate between liquid and the soluble solid from a solution, we can use simple distillation. And let's take the example of a solution of seawater, for example, which is containing salt. So to separate between water and salt from seawater, we can proceed by the simple distillation, in which we will be heating the solution, producing a vapor of the water. This vapor will rise through the neck and passes through the condenser. So the gas will pass through the condenser and change state from vapor into liquid. Then it can be collected as pure H2O in the conical flask. At the end of the experiment, we will see salt crystals which will be left in the bottom of the round bottomed flask. And to separate between two or more liquids that are miscible, for example, an alcohol and water, an alcohol such as ethanol and water, we can use the fractional distillation. So As you can see in the apparatus here, this is different set of apparatus compared with the simple distillation. Actually, the difference is in this part here, because in the fractional distillation, we have the fractioning column, which is containing glass beads, small glass beads. And actually, this is due to the fact that we want here to have a gradient of temperature in this column, which is the fact that will be allowing us to separate between the two liquids, which have different boiling points. Actually, the solution here, which is containing a mixture of ethanol and water, will be heated to the temperature of the substance with the lowest boiling point, which means in this case, because ethanol has a boiling point of 78 degrees Celsius, while water has a boiling point of 100 degrees Celsius. So here we will be heating the mixture until it reaches 78 degrees Celsius, which is the boiling point of ethanol. Then the ethanol boils and distills out by passing through the condenser, where it will change state from gas into liquid. At the end of the experiment, all water will be left in the round bottomed flask. Thank you for watching and see you next time. Goodbye for now.